Good morning, students. This is Max class, and I hope all you might have completed the yesterday's homework. So, today in this class, we are going to learn a new topic, permutations, which is related to factorial, what we learned yesterday. First, we will recall the factorial. What is that factorial? Factorial is factorial of a natural number n is the product of first n natural numbers. Is the product of first n natural numbers. So, n factorial is equal to 1 into 2 into etc. up to n. And we know 0 factorial equal to 1 and 1 factorial equal to 1. See, if we write it as a function, see, f is from capital N union 0 to n, where n is a natural number. This is the factorial. The answer we will get only as a natural number. This is domain and this is range. All our answers will be a natural number. Here, for 0 we can find out. For the negative numbers, we cannot find out the factorial. That is why n union 0. Okay. This is single factorial, isn't it? Using double factorial, we don't have any problem. Just for your knowledge. Double factorial, how to find it out? For example, okay, let it be. First, we can write the formula. N double factorial is equal to 1 for n equal to 0. Then n into n minus 2 into n minus 4 into etc. up to 4 into 2 for n is even. Then n into n minus 2 into n minus 4 into etc. 3 into 1 for n is odd. This is the formula. Okay. For n is even. For example, we can do that 6 double factorial means 6 into 4 into 2. 2 anyway we have to subtract. So, you need not to learn the formula. Directly you can do it. See 7 factorial. 7 double factorial equal to 7 into 5 into 3 into 1. Is that clear? Just 2 we have subtracted. And now n double factorial is not equal to n factorial into factorial. See, this both are not equal. Shall we check it? We can check it with the 4 factorial. Okay. 4 double factorial. As per this formula, if we do 4 into 2, which is equal to 8. 4 factorial into factorial. 4 factorial. What is that 4 factorial? When we write 4 into 3 into 2 into 1 into factorial. Is it not? So, when we do 4 into 3, 12. 12 into 2, 24. So, 24 factorial. Is it both are equal? 24 factorial when we do, we will be getting a big number. 24 into 23 into etc. So, this 4 double factorial is not equal to 4 factorial the whole factorial. Okay. So, double factorial and single factorial we have learned. Now, we can learn what is permutations. The number of distinct permutations of R objects which can be made from n distinct objects is n factorial by n minus r factorial, and it is denoted by NPR. N should be on the top and R should be on the base. This is how to read it, NPR. See, number of distinct permutations of R objects which can be made from n distinct object. Example, we will derive that formula. We have 7, okay, So total here we have 6 letters, isn't it? Among the 6 letters, need only 4 letters. Okay? Select any 4 letters or 4 letters string we need. Okay? So this A, B, C, D, E, F, total we have 6. From 6 we need 4 letter string. So 4 letter string, how we will write it? 4 dash we will make it, isn't it? So 6, 5, 4, 3. Am I right? This is the way we will be using. 6, 5, 4, 3. So the number of strings is equal to 6 into 5 into 4 into 3. Isn't it? This is what we used to do. Now I am going to complete it. This is equal to 6 into 5 into 4 into 3 into 2 into 1 divided by 2 into 1. Value did not change. Numerator and denominator I have multiplied by 2 into 1. What is the meaning this? 6 into 5 into 4 into 3 into 2 into 1. This is 6 factorial and the denominator is 2 factorial. Or this can't be written as 6 factorial by 6 minus 4 factorial. 6 minus 4 is 2. So total number is 6. That is n is equal to 6. And you see we need 4. So I can take r equal to 4. So as per this when we write, this is n factorial by n minus r factorial. From this only we have got this permutation formula. Okay, n factorial by n minus r factorial. Theorem: if n comma r are positive integers and r less than or equal to n, then the number of permutations of n distinct objects taken r at a time is n into n minus 1 into n minus 2 etc. up to n minus r plus 1. The same formula only. Okay. See here we have taken n equal to 6 and r equal to 4, isn't it? The same way. How much we got it? 6 into 5 into 4 into 3. This is the answer, isn't it? See here r, the same value when we substitute here. 6 into 6 minus 1, 5 into 6 minus 2, 4 into n minus r plus 1, the last term. 6 minus 4 plus 1, 6 minus 4, 2 plus 1 is 3. Correct one, Leno? Yeah, this is a formula. Anyway, we have made it as n factorial by n minus r factorial. Otherwise, our answer will be n into n minus 1 into n minus 2 etc. up to n minus r plus 1. See, note, npr will be equal to 0 when? If r is greater than n. Always this value should be less than n. Imagine from 6 we have taken 4. From 6 letter, is it possible to take 7 letter word? All letters should be distinct. Is it possible? Only 6 letter is given and they have asked us to find out maybe 8 letter or 9 letter. All should be different letters. Is it this is impossible. Therefore, our answer should be 0. And npn equal to n factorial. Why? What is the reason? See the formula n factorial by n minus n factorial, because r equal to n we got it. When we substitute n equal to n minus n equal to 0, 0 factorial, we know that 0 factorial is equal to 1. Therefore, npn will be equal to n factorial and np0 is equal to 1. Because no value we can substitute here. npn or np0 means n factorial by n minus 0. Is it not? Say np0. That means n factorial by n minus 0 factorial. We may get n factorial by n factorial. Both will get cancelled. Therefore, our answer is equal to 1. Okay. So, these points we should remember. Now, properties of permutations. 3 properties are there. We will learn and move to the problems. Okay. So, first one, npn is equal to np n minus 1. Actual formula we know NPR is equal to n factorial by n minus r factorial. NPR equal to n factorial by n minus r factorial. We will take first right hand side. NP n minus 1. Substitute in the formula n factorial by n minus r. In place of r we have n minus 1. So n minus 1 factorial. Now n factorial by n, give the minus inside, minus n, minus into minus, plus 1 factorial. So plus n and minus n will get cancelled. So we may get n factorial by 1 factorial. Or n factorial by 1 factorial, our answer is 1. See, this can be written as n factorial by n minus n factorial. N minus n means 0 factorial, isn't it? 0 factorial, then value is equal to 1. So we can write which is equal to npn. That's what we need to prove. Or else from this step also directly you can write which is equal to npn, because we have learned npn is equal to n factorial. Using that also you can write it. Now coming to the second one, npr is equal to n into n minus 1 p r minus 1. Here also the same way we will take right hand side and prove which is equal to left hand side. See, the same formula we are going to use. NPR is equal to n factorial by n minus r factorial. So what is given? N into n minus 1 p r minus 1 equal to n into, substitute in the formula, n factorial, n minus 1 factorial by n minus r. So n minus 1 minus of r minus 1 factorial. See, n into n minus 1 factorial by n minus 1, give the minus inside, minus r, minus into minus, plus 1 factorial. Now minus 1 and plus 1 will get cancelled. See here, n into n minus 1 factorial is n factorial, isn't it? Divided by n minus r factorial. What is this? This is the direct formula of NPR. This is what they have asked us to prove. So we have got it. NPR is equal to n into n minus 1 p r minus 1. Say the same thing we can write it as n into n minus 1 into n minus 2 p r minus 2. Continuously when we expand, at last step we may get n into n minus 1 into n minus 2 etc. up to n minus r plus 1. So that is what we learned in the first theorem. Okay. Now the third property. Third property is NPR is equal to n minus 1 PR plus R into n minus 1 P R minus 1. Shall we prove it? Say proof. Here also anyway we have to use the same formula. NPR is equal to n factorial by n minus r factorial. This is what we have learned. Right hand side what is given? N minus 1 PR plus r into n minus 1 p r minus 1, which is equal to, what is this? When we substitute in the formula, n minus 1 factorial by n minus 1 minus r factorial, isn't it? Plus r into the same thing. This when we use the formula, n minus 1 factorial by n minus 1 minus r minus 1 factorial. Okay. See, n minus 1 factorial by n minus r minus 1 factorial. Just I have arranged the alphabet first and the number second. Here r into n minus 1 factorial by n minus 1 minus r minus into minus plus 1 factorial. So here minus 1 and plus 1 will get cancelled. So n minus 1 factorial by n minus r minus 1 factorial plus r into n minus 1 factorial by n minus r factorial. See, the numerator n minus 1 factorial both same, but the denominator among these, which is greater ma? N minus r is greater, isn't it? So we can reduce that. See, n minus 1 factorial by n minus r minus 1 factorial plus r into n minus 1 factorial by n minus r factorial. How to write it? N minus r into n minus r. From that we have to subtract 1, isn't it? N minus r into n minus r minus 1 factorial. So now n minus 1 is common in the numerator factorial and the denominator n minus r minus 1 factorial. So here totally we have taken out 1 plus here r by n minus r. See here n minus 1 factorial by n minus r minus 1 factorial into, take LCM, LCM is n minus r. So here no number is there. Now I have given n minus r. So the numerator must be multiplied by n minus r plus r. R is there, isn't it? See, which is equal to, I am writing n into n minus 1 factorial by n minus r into n minus r minus 1 factorial. I have just arranged in the order. Now n into n minus 1 factorial is n factorial. Denominator n minus r into n minus r minus 1 factorial means what is the meaning? N minus r factorial. Actually this is the direct formula of NPR. This is what they have asked us to prove. NPR is equal to n minus 1 PR plus r into n minus 1 P r minus 1. Possible is there to ask. Okay, important question. Now shall we move to the problems? See, example 1, evaluate 4P4, 5P3, 8P4, 6P5. You have two methods. One is either you can use the formula NPR equal to n factorial by n minus r factorial, or NPR is equal to n into n minus 1 into n minus 2 etc. up to n minus r plus 1. Any one formula you can use it. See the shortcut method also I will tell you. The first one is 4P4. As per this, when you use 4 factorial by 4 minus 4 factorial. So you may get 4 factorial by 0 factorial. That is 4 into 3 into 2 into 1 by 0 factorial is 1. Therefore our answer is 24. This is one method, isn't it? Or as per this formula means how will you do it? 4 into 4 minus 1, 3 into, last step what is there ma? N minus r plus 1. So 4 minus 4 plus 1. 4 minus 4 is 0. 0 plus 1. So till 1 we need. So 2 into 1. 4 into 3, 12. 12 into 2 is 24. This is also using this formula. Okay. Or one more shortcut is there. No need formula. Here 4 is there, right? So 4 times you have to write in the descending order. See, product of the descending order. Let me tell you the second one. See, 3 means, as I said, 3 times in descending order, right? 5 into 4 into 3. This is the answer. 20 into 3, 60 is the answer. If you want, you can check using the formula also. See, in the formula if you use or 5 factorial by 5 minus 3 factorial. 5 factorial, 5 into 4 into 3 into 2 into 1. 5 minus 3 is 2 factorial. So 2 into 1. So what we are getting? 5 into 4 into 3. Even you can use in this step also. 5 into 5 minus 1 is 4. Last step may be 5 minus 3 plus 1. 5 minus 3 is 2. 2 plus 1, 3. So 5 into 4 into 3. Till that we have to stop it. So better you can, as I said, you can use the symbol method. 8P4. So 4 is there. So 4 times the product of the number in the descending order. So 8 into 7 into 6 into 5. Very simple, isn't it? No need of formula. This, when we multiply, we will be getting 1680. Okay. The fourth subdivision is 6P5. So 5 times in descending order. 6 into 5 into 4 into 3 into 2. Yeah. 30 into 4. 120. Yeah. 720 is the answer. Is that clear? You can use any one formula method or that shortcut what I told you to do it. Okay. Now the next problem. Example 2. If n plus 2 p4 is equal to 42 into np2, find n. So given n plus 2 p4 is equal to 42 into np2. From this we should find n. Okay, n plus 2 p4. That means 4 times we have to write it in the descending order, isn't it? So when we decrease, how much we will be getting? N plus 2 into n plus 1 into n minus 1 equal to 42 into, here np2, 2 times write the n in descending order, n into n minus 1. Okay, bring n to the left hand side. So n plus 2 into n plus 1 into n minus 1 divided by n into n minus 1. See, n and n minus 1 will get cancelled. So n plus 2 into n plus 1 is equal to 42. Shortcut method is also there, or else what you should do? Multiply, bring it in a quadratic equation in n, simplify, factorize and find out the value of n. Or, see, we know that 42 can be written as 7 into 6, isn't it? 7 into 6 is 42. Here also the next number, isn't it? That is why I wrote it. Now equate it. N plus 2 is equal to 7. Biggest value to biggest. See, n is equal to 7 minus 2, n equal to 5. Here also if you equate, we will be getting n equal to 5. Therefore, the answer is n is equal to 5. Simple only, no? Example 3. If n minus 1 p3 is to n p4 equal to 1 is to 10, find n. So this is given, we should find n. See, solution given n minus 1 p3 is to np4 is equal to 1 is to 10. Actually this is fraction, isn't it? Say n minus 1 p3 by np4 is equal to 1 by 10. Now here 3 times we have to decrease this. N minus 1 into n minus 2 into n minus 3 divided by np4. So 4 times we have to write the n in descending order. N into n minus 1 into n minus 2 into n minus 3. So 1, 2, 3, 4. Okay. Which is equal to 1 divided by 10. N minus 3 and n minus 3 will get cancelled. N minus 2, n minus 2. Oh, very simple. See, 1 by n equal to 1 by 10. Cross multiply. 10 is equal to n, or which implies n is equal to 10. Is that clear? See, almost we have did the sums in this permutations. Okay, copy down all the sums in your notes. Today there is no homework for you. We may meet after 3 weeks, I think so. In between, the 2 Gen staff will take the classes for you. Okay, be safe. Thank you. Bye-bye.